This video describes the calibration of the FET500 limiter. You'll need some test equipment and tools to do these calibrations. First, a function or signal generator that can output a 1 kHz sine wave. An AC voltmeter, such as a Hewlett-Packard 400 series. A computer with audio test software installed and an audio interface to go with it. A screwdriver, and a 500 rack. It may be helpful to make a jig to apply power and signal to the unit without putting it in a 500 rack. If you don't have an AC voltmeter, you could alternatively use a digital multimeter that can accurately measure AC voltages at 1 kHz. Start by generating a 1 kHz sine wave with your signal generator. Set your AC voltmeter to the 1 volt range. Connect the generator to the input of the FET500 terminals. On the 500 rack, that's terminals 8 and 10. Don't connect the signal generator to the FET500's ground. Use your AC voltmeter to measure the input voltage at the input when connected to the FET500, and adjust to ensure that your signal generator is delivering 0 dBm or 0.775 AC volts RMS. Many audio interfaces will struggle to supply sufficient voltage to this input, so make sure you check at the input with the unit that you are calibrating connected. Turn the input knob about halfway up. Now connect your AC voltmeter to the output terminals 2 and 4 of the 500 rack. Do not connect the voltmeter to the FET500's ground. Set your AC voltmeter to measure in the 10 volt range. Increase the output control until the output level reaches 16 dBu or 4.88 volts RMS. Adjust VR1 on the meter board until the peak indicator LED just lights. This sets the peak LED threshold. Set the AC voltmeter back to the 1 volt range. Adjust the output knob until the output measures minus 6 dBu, or 0.388 volts RMS. This time, adjust VR2 on the meter board until LED 201 just lights. That's the second one from the bottom. That completes the output level indicator calibration. Between the attack and release knobs is a hole for the Q bias trimmer. Turn the trimmer fully counterclockwise. You might notice the output LEDs indicating that the signal output is increasing as you turn the Q bias trimmer, but don't worry if it's not. With the same 1 kHz 0 dBm signal applied to the input, adjust the output knob until LED 207 just lights. Turn the Q bias trimmer slowly clockwise until the output level drops by 1 decibel. This sets the FET bias and will ensure that the correct amount of gain reduction is applied to the input signal. Start again with the input knob turned up halfway and the bypass button out. Turn the attack and release knobs fully clockwise to minimize any latency between adjustment and effect. Set the ratio to 20:1 and make sure the gain reduction off button is pushed in. With the same 0 dBm 1 kHz tone applied to the input, turn the output knob until the 2 LED lights on the output level indicator. Activate the gain reduction by releasing the push button and observe the drop in the output. -7 indicates a 9 dB drop from +2. If it falls short of -7 dB, turn the input knob up. If the meter drops more than minus 7 dB, turn the input knob down. Turn off the gain reduction and adjust the output knob again to display 2 on the output meter. Activate the gain reduction and observe the drop. Repeat these steps until the output LED shows a drop from +2 to -7 when the gain reduction is activated. Once this drop has been established, don't touch the input or output knobs again for this calibration. Now we want the gain reduction meter to display the same 9 dB total drop. Turn the gain reduction off by pushing in the GR off push button. Set the zero adjust trimmer until the gain reduction meter shows 0. Note that while they are marked differently, the steps within each scale are identical. Engage the gain reduction by releasing the GR off push button. Observe the drop on the gain reduction meter. If it drops below -9, turn the tracking adjustment trimmer counterclockwise. If it falls short, turn the tracking adjustment clockwise. Turn off the gain reduction again and re-zero the GR meter with the zero adjust. Repeat these steps until the GR meter shows a drop from 0 to -9 when the gain reduction is engaged. For the D and F500, you'll need to adjust the signal preamp for linearity. Connect the FET500 to an audio interface. Practically any interface will do. Connect the output of the FET500 to the input of your audio interface. Connect the input of the FET500 to the output of your audio interface. Apply power to the FET500 and set the input knob about halfway up. Make sure the bypass is not active and that the ratio is set to 20:1. Engage the gain reduction off push button. Start the audio measurement software on your computer. Configure the software to use the interface that is connected to the FET500. Set the software spectrum analyzer to generate a 500 Hz tone. Start the analyzer and increase the output of the FET500. Observe the display. Note that the 500 Hz tone is the most prominent, while there are harmonics at 1 kHz, 1.5 kHz, and so on. Turn the distortion pot on the main PCB through the hole in the meter board until the harmonics are at their minimum. You'll reach a point where the distortion starts to rise again. Back off on the trimmer until the lowest distortion is achieved. Now your FET500 is fully calibrated.